Hi, I'm Priyanka Dhopade and I'm an aerospace engineer at the University of Oxford. My office is in the Oxford Thermofluids Institute where I research jet engines. If you've ever flown on a plane before, you'll know that the engines are the big round things that are hanging off the wings that basically propel the aircraft forward. The jet engine was actually co-invented by two people separately around the same time in the 1930s and 40s. One was a German man and the other was a British man named Frank Whittle. The company that began manufacturing jet engines was called Rolls-Royce, and a lot of my research here at the Oxford Thermofluids Institute is actually funded by Rolls-Royce. Jet engines are actually pretty awesome. They're designed to operate at extremely high pressures, temperatures, and accelerations. For example, when an airplane's taking off, the pressure inside the high-pressure compressor can be as high as 700 pounds per square inch, which is the equivalent of a horse standing on the area that's the size of your thumb. The temperatures inside the hottest part, which is the combustor, can be as high as 2,300 degrees Celsius, which is even hotter than molten lava. The air flowing past the rotating blades can accelerate as high as 50,000 times faster than the gravitational acceleration on Earth. And at some points in the engine, for example in the turbine section, the temperature of the air can actually be higher than the melting point of some of the parts inside. The research we do at the Oxford Thermofluids Institute looks at how we can efficiently cool the hot parts of the engine using cooler air taken from the front half of the engine. Basically, this stops the hot metal parts from melting, but it also makes the entire engine more efficient so that it emits fewer harmful gases like CO2 and is better for the environment. What I do is I create computer models of the inside of the engine so we can understand how the air is flowing and transferring heat to the metal parts. And I collaborate with other researchers who can build physical models of some of these parts and test them in our lab. Once we understand the physics behind the aerodynamics and heat transfer, we can then design better cooling systems for the next generation of Rolls-Royce engines.
A 350 gas broadcast.